Hello everyone, Maui again, and starting from this week, or should I say a video, we're going to start a new web hacking series. We will use Portswigger platform, and if you don't know what's a Portswigger, a little background, it's a web-related organization that have plenty of web hacking labs, activities, they have modules to teach web hacking, as well as they're the one that created the tool Web Suite. And so we're going to cover their content module by module because they're divided into modules. Each module is listing one vulnerability and all its variations. So if you logged in into your account, you can go into Academy and then you will be faced with this page. In here you can scroll down, you have your learning progress and you have your labs that you finished. You have your whole progress over here. As you can see here, you have your labs. You can just view all and go to other labs, and here you have your certification, which I still didn't cover. So we'll start with the 8 modules or the most related modules to the certificate, and then we'll move to the other modules. So you can click on learning paths and then scroll down. Here you can see all the learning paths that teach you how to do web hacking. They still didn't upload all the paths for all modules, but we will cover the ones here, and then for the ones that are not here, we're going to create our own. So in today's video, we're starting with the SQL injection, which I already have opened here. So let's get started with that. What is SQL injection or SQLi? SQL injection or SQLi is a web security vulnerability that allows an attacker to interfere with the queries that an application makes to its database. This can allow an attacker to view data that are not normally able to retrieve. This might include data that belongs to other users or any other data that the application can access. In many cases, an attacker can modify or delete this data, causing persistent changes to the application's content or behavior. In some situations, an attacker can escalate an SQL injection attack to compromise its underlying server or the backend infrastructure. It can also enable them to perform denial of service attack. So as you can see here from this little explanation, SQL is a critical vulnerability when it's found because it can change the behavior of the application, delete some data, add some data to it, or modify, read some data from the server. So it's a critical vulnerability when it's found. So let's continue. How to detect SQL injection vulnerabilities? You can detect SQL injection manually using systematic set of tests against every entry point in the application. To do this, you typically submit. So before continuing, what I mean is that any entry point that you can have to the application, let's say via the URL or via any input box that you can enter, you can try to test for the SQL injection. Let's continue. The single quote character, and look for errors or any other anomalies. Some SQL specific syntax that evaluates to the base original value of the entry point and to a different value, and look for systematic differences in the application responses. Boolean conditions such as or, 1 = 1 and or 1 = 2, and look for differences in the application's responses. Payloads designed to trigger time delays when executed with SQL queries, and look for differences in the time taken to respond. Host payloads designed to trigger an out-of-band network interaction when executed with SQL queries, and monitor any resulting interactions. Alternatively, you can find the majority of SQL injection vulnerabilities quickly and reliability using port scanners, and this is under perp scanner. And additionally, I will give you one more resource to look at when it comes to finding an SQL, and that resource is in GitHub called payloads all the things. It's a GitHub repository that contains all the payloads when it comes to all web attacks. So let's just open it. As you can see here, you have different type of attacks that you can click into and navigate. We're interested in SQL, we can just write it here or just navigate into it. SQL injections, and then you can just scroll down and you will see all the payloads that are related to SQL. You can click on anything, let's say this one, and then it will give you all the explanation and payloads to try. Another great resource will be W3 School, which we'll get into soon. Let's continue. SQL injection in different parts of the query. Most SQL injection vulnerabilities occur within the where clause of a select query. Most experienced testers are familiar with this type of SQL injection. However, SQL injection vulnerabilities can occur at any location with the query and within different query types. Some other common locations where you can find SQL injections within the update values of the where clause, in an insert statement where you insert new values to the SQL, in select statement within the table or column name, in a select statement again, but this time then the order by column. rows, and we'll get into all of these soon. Retrieve hidden data. So how do you retrieve hidden data from the database? Because SQL is just an attack that deals with the database, the application. So let's say I'm the owner of the application and I'm putting some of my products on the web page, keeping other products hidden. So you can retrieve these or those hidden data using these techniques. Imagine shopping application that displays products in different categories. When the user clicks on the gift categories, their browser requests the URL insecurewebsite.com/products to add a parameter, and this time it's category equal gifts. So you will retrieve all the categories from the products that have the value gift. This causes the application to make an SQL query, but on the backend, to retrieve details of the relevant products from the database. This is an SQL format, and if you don't know that, we'll check it with W3 School. So you have a select statement. This asterisk or a star means everything from products. Products is a table where category equals to gift and released equal 1. This means that all the products that are released, and you can change this one to a 0 or anything else we will be seeing. This SQL query asks the database to return all details asterisk from the product table where the category is gift and released is 1. The restrictions is that the released is 1 is being used to hide products that are not released yet. We could assume the unreleased products equal release equal 0. So in this case we can test by changing the 1 to 0, but in here we don't have anything to change. This is the URL that we're making, but this is what's happening on the backend. So how do we change and add the release into here? Let's continue. And now the application doesn't implement any defenses against SQL injection attacks. If it doesn't implement any defenses, this means an attacker can construct the following attack. For example, when it comes to the category, you add a single quote and then dash dash, and this will mean comment. So coming back to that same SQL query, you will comment everything that comes after gift. So you will retrieve all the products that have the release of 1 and 0. And let's view the query again. You have a select star from products where category equal gifts. As you can see here, you added a single quote and this 2 dashes. So this is the whole category now, but the SQL will take this single quote and close the gifts and take this as a comment and comment everything after it. Crucially, note that the dash dash is a comment indicator in SQL. This means that the rest of the query is interpreted as a comment, effectively removing it in this example. This means that the query no longer includes and release equal 1, and as a result, all products will be displayed, including those are not released yet. You can use similar attack to cause application to display all the products in any category, including categories that they do not know about. So in here, you can say that I want the category gift, but you're adding single quote, and this is a space in URL encoding to a plus sign, or 1 equal 1. This means that this will always evaluate to true because 1 is always equal to 1. So it will go to the SQL query and retrieve everything from the database, all the categories. And lastly, you comment so you don't cause any errors on the server side. This modified query return all items when either the category is gifts or 1 equal 1, which is always true. The query returns all items. Here we have a warning. Take care when injecting the condition or 1 equal 1 into an SQL query. Even if it appears to be harmless in the context you're injecting into, it's a common for applications to use data from a single request in multiple different queries. In your condition reaches an update or delete statement, for example, can result in accidental loss of data. So what does this mean is that let's say that you're instead of selecting stuff, you're deleting. So you're trying to delete a gift where the release is 1, and then you mistakenly go and add or 1 equal 1. You will delete everything within the category. So just make sure you know how to inject and when to inject. Continue. We have our first lab, and this is SQL injection vulnerability and where clauses allowing retrieval of hidden data. This lab contains an SQL injection vulnerability in the product category filter. When the user selects a category, the application carries out an SQL query like the following: select star from products where category equal to gift and release equal to 1. To solve this lab, perform an SQL injection that causes the application to display one or more unreleased products. And as you can see here, we have the solution which is written, and we have community solutions which are videos made by the community. So let's access the lab. Ideally, I would access it using Burp Suite's browser, but in this case I don't need it, so let's just continue with normal browser. And here we have the lab format. As you can see here, we have product, and assuming that all of them have the release equal to 1, and here's our categories. So for example, let's click on the gift since we were dealing with gifts all the time. As you can see here, we have a new filter and the category is gifts, and it's telling us to show more of the unreleased product. So we can start by testing the URL. Let me add just a single quote and see what happens. As you can see here, we got an internal server error, and this is indicate that it's vulnerable to SQL. Now let's go back. Let's add our quote again. Space. We can deal with it in two other ways. We can say and released equal to 0 and comment everything after it. And as you can see here, we got the unreleased product, which is couples umbrella. Or what we can do is we can just delete this, go back to gifts, and we say or 1 equal 1, which will always evaluate to true and return me every product in the on the gifts. Click enter. As you can see here, the lab is solved, and scroll down and see we have every product from released and unreleased. So we retrieved all the products successfully. So let's move to the next lab. Let's go back in here and let's continue. Subverting applications logic. Imagine an application that lets the user log in with their username and password. If a user submit the username Winer and the password Blue Cheese, the application will check the credentials performing by the following SQL query. Select star from users where a username is Winer and the password is Blue Cheese. If the query returns the details of the user, then the login is successful, otherwise it is rejected. In this case, an attacker can log in as any user without the need for a password. They can do this using the following SQL comment sequence, as we learned before, to remove the password checks from the where clauses of the query. For example, submitting the username administrator, giving it a single quote, comment, and a blank password will result in the following query. You have your select star from users where the username is administrator. The single quote that you added will close the administrator name, and then you added a comment which will comment everything after it. And now for the database, it will check if the username is administrator and it will return his information. So now the password is no longer needed. This query returns the user whom or whose username is administrator and successfully logs it as the attacker of the user. And now we have a lab, SQL Injection vulnerability allowing login bypass. This lab contains an SQL Injection vulnerability in the login function. To solve the lab, perform an SQL Injection attack that logs into the application as the administrator user. So this is our goal. I will copy it, and now let's access the lab. The lab has rendered. We have the home page, as you can see, normal stuff, but we want to go to my account to log in. As you can see here, we can log in as, let's say, administrator, and I will write any password. So I'll write anything. As you can see here, you get an invalid username or a password. So what does that mean is that it checks it on the backend on the SQL and sees that I don't have that password of the admin. So now I'll paste the same username. I will add single quote, comment, and then for the password I will just enter anything again as before, and I will try to log in. And as you can see here, I've successfully logged into the application without providing the correct password of the admin. So this input was SQL injectable, and let me bypass the password. So that's it for this lab, and I will provide some additional resource, which is W3 School. So going to W3 School, I'm writing SQL. This is a great resource when it comes to SQL. If you don't understand this language, you can come here and play with it, try yourself. You can go to the where clause or any other different clause, and then start testing to up your skills when it comes to SQL injections. And with the next video, we'll be explaining lab 3 and 4, and we'll get into union attacks and determining the number of columns required. So thank you, and see you again in the next video.